So, Anders Sjöström, some of you may have run into me in the SIPA context, the correlative process and image analysis infrastructure that Medfac is paying for. That is where I ran into Kajsa. I'm also working in the InfraVis infrastructure, which is a national infrastructure for visualizations of scientific data. Now, that may seem a bit far off from the Hanseatic Science Cloud, but that's, and it is, but that's also due to the fact that I've been working with a number of Nordic projects on data sharing and resource collaborations and resource sharing across the borders. First with the Dellinger project, which shared computational resources across nation borders, and later on now with the Puhuri project, creating the access system for the Lumi supercomputer in Finland. So that's enough about me, and then we have Emma-Lisa.
Thank you, Anders. Emma-Lisa Hansson. I also work at LUNAC. You may know me in the context of research data architecture. I have constructed one report together with a colleague on LU's research data architecture, and also in national context on storage for data. And I also work with EOSC Nordic.
So Emma-Lisa is the one who's actually doing the legwork in this project. She's been doing all of the interviews and the transcription of that, and also the better part of the gathering of all the information that we need. Emma-Lisa is working 70% in this project, being the young researcher, and me as the project manager on the Swedish side is working 30%. And then we also have Anders Bjurendal at DTU working with the project as a co-supervisor. We have also a number of participants from Denmark, Sweden, and Germany, because we realized that it would be pointless for us to start a feasibility study like this without involving all the partners that could conceivably be interested in this. Right. So the next slide, if you please. Oh, we haven't even shared the slides. So.
I haven't even started sharing them. I will start sharing them now.
Yeah.
Let's see, and I will just there.
Yeah, just one brief mention of that logo that you see there. That is absolutely not the final logo. It's a tentative logo we created just to have something when we were talking about this, because it's easier to present a picture than a lengthy sentence. So next slide, please. Right, so as Kajsa mentioned, this is funded by the Halles project. And when you look at this, with all the participants here, how would you even begin to think about creating a cloud that would cater to the needs and the interests of all of these parties? So that is kind of what we are dealing with. You see at least 3, even 4 countries here. And it is, no, it's actually 3 countries. That's the old German border. Never mind. You see a number of countries here, well, and you don't see Oslo, but it's, I believe it's up there. And sharing data, sharing resources across these borders is not a trivial task. So if we take the next slide. So the Hanseatic Science Cloud feasibility study, because this is what it is. It is to investigate the possibility of creating this science cloud, and we'll come back to what we mean with the science cloud, with the long-term goal of creating a scalable cloud, which is easy to use for the researchers, it's efficient and secure, and those are the guiding principles of this cloud. We aim to serve both the industry and the academia. And initially, we will focus on the needs of the users of the large-scale research facilities. I mean, the facilities that are serviced by Halles, Max 4, DESI, XFEL, ESS. And we have a in the project description that we had, we also have a timeline of what we are planning to do, and we are currently in time. We are in week, I think, 16 now, which is on the border of the blue and green, and in the project time we are around where this says last interview. So you see we're running slightly behind. Do you have anything to add to this, Emma-Lisa?
Yes, we had the last interview a few weeks ago. I will talk a little bit more about the interviews later on. We are currently transcribing also then, so I'm on the last few interviews now to transcribe. So we are also a little bit on the work package 3 also that we will talk a little bit more of.
Yeah. So you take the next slide then.
Yes.
So a bit of a complexity of a science cloud. I mean, there are a number of questions that you need to explore when it comes to these types of beasts. For instance, who are the actors? Who are the stakeholders? Which ones are we to talk to? Which ones are we to service? Which ones will service others? And how do they intermix? Also, the HSC, the Hanseatic Science Cloud in the ecosystem. I mean, there's a call coming up in June for an European federated cloud sponsored by EuroHPC, aiming to create a federated cloud of resources throughout Europe. How would we compare to that, and where is our place in that? They are building the high-speed European network. We have European HPC resources and infrastructures, EOSC Nordic, with the work package 1 through 6, where Emma-Lisa is working, and 2 and 3, I think it is.
Yes.
How does this proposed cloud compare to the CERN data management, where they have been doing kind of these things for, I'd say, the better part or even more than 30 years? Sharing and accessing data, what may be shared, what can be shared, who should have access and who can grant access. Looking at the sharing part, what may be shared from a legal standpoint, what can be shared from the standpoint of the projects that are creating the data. I mean, first dibs on the data to write the articles, for instance. Who can grant access? We said that. Who should not have access? Where are the data? When are data? And that's quite important, because where are data? I mean, where in this cloud do they physically live? But also, at what point in time do they need to be at what point in space? Then we also have the issues of data compatibility. I mean, different file systems, different file formats, different modalities. How did you gather these data? How do you handle metadata? What is metadata, and is it needed to understand the data at all? The paradata, which is a part of metadata, but I would like to stress that it's important to think about paradata in order to be able to understand what you have. Where I have an attempt to definitions of metadata and paradata here. And it all needs to be fair, otherwise this won't fly, because we are in the era of EOSC. And I think that was all I had to say on that slide. So then it comes to the interesting part of data sovereignty and data security. We need to adhere to be compliant with laws and policies. Absolutely. Data are subject to the laws of the current jurisdiction, wherever that is. And that could be national or international, or the jurisdiction of the private companies. That is to say, their own ideas of what you can and can't do with data. And you also need to be aware of that. We also need to be aware of where in space is the data located. As I said before, if you have data in, say, for instance, Denmark with personal information, Are you allowed to move that outside of the borders of Denmark? Maybe, maybe not, depends on who you ask. And if you're accessing it through a cloud, have you moved it across borders? If you are just looking at the data and the data is still residing in the country and you're operating it there, but you're looking at it here. That's also something to think about in the context of laws and policies. There are policies and European data protection laws that needs to be further investigated. We only touched upon those so far and must be further investigated. We can also have the problems of policy documents that are nationally oriented. I mean, you write most often a policy document to service a need. If you only have written that policy document to service the need of the current entity, then you are most likely not being looking at the needs of other entities or other actors. And of course, the same goes with academic service providers, but that's generally the other way around. Many researchers are collaborating with researchers in other countries. So if you have a policy that's nationally oriented and you have a collaboration that is multinational, you run into problems. You need to handle this. There is harmonization being discussed. It's early stages now, and as I said, this is in the EOSC era, so it will have to be discussed and is discussed, but it's early stages. And then we also, of course, have the cross-border collaborations and the industry. As I said, the everyday work for researchers include cross-border industry collaborations. Data is collected in one place, shared in another, and managed in many different locations. All of these things has to be accounted for. Do you have anything to add on that slide, Emma-Lisa, or should we go on?
The complexity of this is huge, to say the least. Yeah. Just the cross-border collaborations and with the industry, the complexity of that is a big question also. So yeah, that's just what I would like to add. Okay, then I shall continue. So for the work package 1, we're doing a review on existing solutions. So we started doing this review, but we are also re-reviewing it as we go because we find new things to look at. We have different projects and everything to look at. We have SNCC Project 5, Supercomputer Lumi, LUNAC Desktop, Presto, and so on and so on. All of this are existing systems and solutions, and they address to software to users, cross-border collaborations, data orchestration, accounts, and software stacks, directions for how to manage your research data, and also cloud infrastructures. So this is a lot to take in and take on in a cloud design, of course. And also for doing this, we also need a nomenclature. This means that we need to have a joint language to talk about. If I say something, then Anders must also know what I am talking about, and all of the partners must know what we're talking about, and also everyone that is included in this cloud design. So that's why we have a nomenclature. It's a large document. It's building up. Let's see. And for the work package 2, we are investigating the needs and the requirements of the users. That is both the researchers as the research providers, and they are both academic. And we also had one tech company that we wanted to interview, and we have interviewed. So we have 12 interviews conducted. They are semi-structured. We did a semi-structured interview guide. So we allowed ourselves to go beyond a little bit on the questions if we found something that was very interesting to dive into deeper. All of these are transcribed with a transcription tool. This is done manually, labor work. Everyone that has transcribed something knows that it will take a lot of time. It will also allow us to go through the material and also look into the transcriptions. And in work package 2, we wanted to know what researchers use today, as one researcher said that everything with IT is difficult. So that's what we're dealing with. They are dealing with data, existing solutions, costs, collaborations, expertise on data analysis. That data that is handled is it's sensitive data, it's industry data, it's large data sets and so on. So we have large sets of data. We have existing solutions. Research groups, they buy their own on-premise solutions. They buy a giant computer and they do their computation on that computer. They also have backups at servers, but they say that they cannot work with the data that is on the server. That they need to download it onto a hard drive, and then they work on it with the hard drive, and then they upload it again, and so on. And all of these hard drives, they bring them with them to these infrastructures, and then they download the material and bring their hard drives home. And then I asked them, what would happen if you would lose your hard drive then? Well, that would be a disaster, of course, because then they would lose all of their data. They also find that there is a lack of available infrastructures. It has mostly to do with data storage and so on. And the existing solutions for the intermediary storage are not suitable because the data sets are too large, of course. They need more capacity. All of this comes with a very high cost for the researchers, of course. So they fund it with their research funding. The collaborations, they are national, they're international, they work with industry, and they work with hospitals. They also feel that they need more expertise on data analysis, code writing, software developing, image processing, and so on. They also need better communication. They want to find a way to understand each other between infrastructures and researchers, because researchers, they do the research, but they are maybe not that acquainted with the code writing and so on. Let's see, I will go to the next page. Then we asked the researchers, what would be your cloud dream? If you could dream freely, what would you like to have? Availability was very high on the list. They also wanted the data to be accessible, so they could reach all of their data in one place, and also all of the tools that they need. They would like a single point of access, so very easy to log on to a system. They want different layers of accessibility for different needs, depending on if you're a user or if you're a programmer and so on. Machine learning is coming very fast, they say. So this has to be also taken into account in a cloud. Let's see, and they already have existing resources, of course. They would like to have licensed software, or at least a selection of software analysis on a cloud. As I said before, easy login. They also wanted to have guides available and documentation on how to use a cloud. It should be easy to use, very simple. The researchers want storage space, data access, being able to reach and work with their data sets very easily. For the researchers that have sensitive data, they want a protection for that sensitive data, of course. Programmatic, image decks, exports of images, for instance, easy downloading of an image, for instance, for a presentation and so on. Metadata harvesting and standardized data formats, and also data sharing, of course, because they collaborate a lot. The next step was that we then asked them, from your dream system, what would be the must-have? Licensed software was very high on the list. Easy, accessible, and control over the accessibility to data during projects. Download and storage and share data was also a must-have. Sensitive data with legal requirements, of course. Metadata, it should be user-friendly. There should be a data management plan integration so that they could plan the project in the cloud. So for instance, if they would plan how much storage they would like to have, then that could be planned from the beginning, and then we would also know when the project is done and should be archived. Available guides was also very high on the list. Experts for analysis. It should be high speed, big size, of course. Standardized data formats was also something that was discussed.
Right. So how would you build a beast like this? What will be the design philosophy of this? Following the dreams and needs and wants from the researchers, and also knowing a little bit of what is actually possible from the provider side, we came up with a solution like this. The high level design like this is that we have an abstraction layer indicated by that square below the cloud, which ensures that the user experience is uniform across the resources. And we want to be as accommodating as possible so that the existing local solutions and systems can be used as much as possible. That is to say, if you have a very particular file system at resource C and a completely different file system at resource A, you as the user shouldn't have to worry about the ins and outs of those file systems. It should just work from the user point of view. So we want to be able to handle that. We are looking into the underlying systems and solutions, and we have ideas on that. So take the next slide here. So on the high level design then, let's say we have the case of Alice, who has a data. She has data at resource facility A, B, and resource C. All of these data are distributed, so a portion at A, a portion at B, a portion at C, but to Alice, they are all presented as data. They are presented in a top-level file system, as it were. They should be accessible regardless of which resources are hosting it. And as I said earlier, we don't care if they are using Lustre or if they are using Dcache or whatever they are using. It just should be able to be presented. To be able to access all of these facilities and the data that are located there in a secure way, we will need to have a federated login to enable this seamless access to data. There is just that. We need to, of course, adhere to the FAIR principles. So to do that, we will most likely also need to have automatic metadata registration. So that is, if you retrieve your data, say from Max 4, you work with that data, and then you will store the resulting files. You will store them back at Max 4 together with the information. I used this data set, I did these things on it, and here is the resulting files. Something like that. So you have a traceability. The physical storage resources located shouldn't have to be identical, as I said, but accessed through the APIs. So we will need to define this API. Or rather, we will not have to define the API because that's already been done in other projects. Data orchestration is also important, of course, but as I said, with other projects, and that's the key issue here with the high-level design. We will not be able to, definitely not in the feasibility study, but even if we are going further to build this system, which we are planning to do, we will need to use what others has been building. So if you take the next slide. Yeah. So using what others been building will allow us to have an access to resources and software. So again, in the case with Alice, who has a program, that program, let's say it needs GPUs. The GPUs are only available at resource A. Your data or her data is at B and C. So she sends off this, starts this workflow, this program. It runs at resource A, and the data is migrated over to resource A because that's where we do the computation. If the data is too large to be moved, then of course the computation has to be moved over to where the data is residing. That's the idea. So we should use the software on the most suitable resource. And again, users don't care what resource they use and shouldn't have to. The availability of software and the data locality will decide where you can do the analysis. And this is a controlled set, so we know where that is. These patterns of usage should be user controllable. What do I mean with that? Well, imagine you have the current situation with pretty much any HPC installation, say, be it LUNARC or be it at NSC or be it at LUMI. There you will be allotted a portion of compute time. That compute time will be distributed for the length of the project. Now imagine you get project time from June to December, but you know that you will not be able to do any computations until October. Then your allotted time will be burned for those 3 months in the beginning. What if you could exchange those for more time in October when you need it and sell that off to someone else? This is something that we are looking into. And this is what we mean with user controllable usage patterns. If I need to use my resources at a particular point in time, then I should do that. If I don't care when I use it, then I should be able to do that. Software licensing is very important. We are working together with or looking at the Presto project, where I have kind of a few fingers in that project as well, to sort out how you would be able to ensure that the user who wants to use a licensed software actually has the license, and that the company that provides the software are okay with you using your license at a different site. This is something that we are investigating with through Presto, and the findings there are very promising. You take the next slide here. How are we for time? We're about 5 minutes, right? Yeah. So risks and mitigations here. So we have actions on data within the system. They must be traceable. So we need to have extensive logging and metadata registration, of course. Raw data, whatever that is, it should be possible to retrieve it, and any data from that set of raw data should be traceable through the metadata information. So we don't meddle with raw data. And of course, if you have a detector that takes an enormous amount of data in and then do a decimation on that and do some magic on it, of course, the produced set there would be the raw data, not what you got from the detector. But we can argue about this, and we would probably pretty soon fall into the realm of religion then. The system should be robust enough to reasonably withstand accidents by users and attacks from bad actors. Reasonably. We can't protect against everything, but if you accidentally delete an important file, you should be able to retrieve it. And we don't want panicking users. If you take the next, this is what we want to avoid. So the next slide then, and I think that might be the last. No, it's not. So on the high-level design of the system, we propose the choice between a good, better, or a best solution. All of these have their pros and cons. Most of what's encompassed in the good solution is again found in the better one, and so on with the best solution. The total cost of a system like this will, of course, increase as you increase the capabilities of the systems. But also the level of integration will also increase. So with the increased cost, you will get better capabilities, as it were. So if we take the next slide, I think we have, yeah. So this is trying to give an image of what you will gain from this, what's the ups and downs and the positive and negative here. So looking at feature costs, if you have the good system, the individual feature will be high in cost, and the individual system cost will be high, and the running cost will be high. Whereas if you go to the best solution, these will decrease. In the same way, the sustainability, scalability, availability, the total system cost and the flexibility will increase, be higher when you go from good, better to best. And as you notice, we have a line there, it's called security. That should obviously be at the same level, regardless of which solution we choose in the end. And I think that may be the last slide, right? Yes. So here are some links to other initiatives. It's by no means an exhaustive list. I think some things that we should be pointing out is the RUSIO, the CERN data management structure. You could look at the instructor Eric Westlife, which is quite interesting. Look at Project 5 from Dyke, and those of you who have not been using the LUNAC capabilities, please have a look at the LUNAC desktop. And with that, I think we are done.